Use the graphical method to solve the following LPP. Maximum Z equal to 2x1 plus 3x2 subject to the constraints x1 plus x2 less than or equal to 13 and x1 minus x2 greater than or equal to 0 and x2 greater than or equal to 3 and 0 less than or equal to x1 less than or equal to 20 and finally 0 less than or equal to x2 less than or equal to 12 where the variable x1 comma x2 greater than or equal to 0. Okay, so solution step 1. So first constraint x1 plus x2 less than or equal to 13. Okay, the condition less than or equal to condition change into equal to condition. Okay, then put x1 equal to 0, that implies that 0 plus x2 equal to 30, we get x2 equal to 30. So the point x1 comma x2 equal to 0 comma 30. Okay, the same way put x2 equal to 0, that implies that x1 plus 0 equal to 30, that implies that x1 equal to 30. We get the point x1 comma x2 equal to 30 comma 0. And step 2, the second constraint x1 minus x2 greater than or equal to 0. Okay, so the condition greater than or equal to condition change into equal to condition and put x1 equal to 0, that implies that 0 minus x2 equal to 0, we get x2 equal to 0. That is the point x1 comma x2 equal to 0 comma 0 and put x2 equal to 0, that implies that x1 equal to 0, so we get same point x1 comma x2 equal to 0 comma 0, that means origin. Okay, and the step 3, so 3 constraint. Okay, so one variable x2 x1 x2. Okay, next we move on the graph. Okay, less than or equal to condition means inside the region and greater than or equal to condition means outside the region. Okay, here the point, first point is x1 is 0 and x2 is 13 and second point is and 13 comma 0. So this is the line. Okay, x1 plus x2 less than or equal to 13. So less than or equal to 30 means inside the region. Okay, like this. Okay, so next one is x1 minus x2, so we get the region. Okay, x1 comma x2 equal to 0 comma 0 and another point we get 0 comma 0. So this is a x1 axis and x2 axis, that is this x axis and here is y axis. Okay, so 0 0 is a region, so draw the straight line. Okay, that is like this. Okay, this is greater than or equal to 0, so is a 0 0 region, so leave it. Okay, and next constraint is x2 greater than or equal to 3, so x2 value is 3. Okay, greater than or equal to 3 means inside the region. Okay, so it is, sorry, outside the region. Greater than or equal to condition, that is outside the region, like this. Okay, and next one is x1 greater than or equal to, sorry, less than or equal to 20. So less than or equal to 20 means here is a 20 point, here is a 20. Okay, so x1 less than or equal to 20, so like this. Okay, and finally last one, the constraint x2 less than or equal to 12. Okay, so is 12, the point 12 is here, so x2 less than or equal to 12, less than or equal to means inside the region, like this. Okay, so like this. Okay, so finally it's intersecting, all the point intersecting is point like this. Okay, all the point intersecting, like first point in a graph is the first point. Okay, this one, and second one is region, so leave it. Okay, and third one, and fourth one, and fifth one. Okay, so all the constraint, okay, all the constraint is intersecting the point. This is the optimal region. Okay, this is an optimal region. Here is A. Okay, put the point A, and here is B. Okay, and here is C, here D, and finally last one E. Okay, okay, next you have to find the touching point. So find the extreme point A, B, C, D, and E. Okay, so find the point A. So the point A touching line is x1, is a x1 minus x2 equal to 0, this line, and x2 equal to 3. Okay, so x1 minus x2 equal to 0 and x2 equal to 3. So x2 value here, so we find x1 value. So x1 value equal to 1. We get the value x1 equal to 3. So we get the point A, extreme point A equal to x1 comma x2 equal to 3 comma 3, and find the point B. Okay, so here the B touching x2 equal to 3 and x1 equal to 20. So here is a point. Okay, 20 and 3, and next we find the point C. Okay, the C point touching is x1 plus x2 equal to 13, and x1 equal to 20. Okay, so we get, okay, like this, x1 plus x2 equal to 13 and x1 equal to 20. So put x1 equal to 20 value in this equation. Okay, we get x2 equal to 10. Okay, so x1 comma x2 equal to x1 comma x2 equal to 20 comma 10. 20 comma 10. Okay, so finally, not finally, is find the value D. Okay, the point D. Okay, the D touching the line is x1 plus x2 equal to 13 and x2 equal to 12. Okay, so x2 equal to 12. So x1 plus x2 equal to 30 and x2 equal to 12. So x1 plus x2 value put here x2. Okay, so 12 equal to 30. So we get the x1 value. Okay, in the extreme point of D we get 18 comma 12. Okay, and finally we find the point E. Okay, so the point E is touching x minus x2 equal to 0 and x2 equal to 12. Okay, so we get the point E equal to 12 comma 12. Okay, so this is a optimum region. This is a B C D E. Okay, this is a optimal region. Okay, and next we find the extreme point, that is the maximum value we have to find. Okay, so the z values corresponding to the extreme points are, okay, here the extreme point a b c d e, and the point x1 comma x2, and maximum z. Okay, here is maximum z, maximum. Okay, maximum z is equal to 2x1 plus 3x2. So the point a equal to 3 comma 3. Okay, substitute the value x1 x2 value here, so we get 50, and the point b equal to 20 comma 3. Okay, put the value here, maximum z equal to 2x1 plus 3x2, we get 49, and c 20 comma 10. Okay, put the value here, so we get 17, and d 18 comma 12. Okay, and put the value here, we get 72, and finally e value 12 comma 12, we get 60. Okay, here the maximum value is 72, hence the optimal solution is maximum z equal to 72. Okay, thank you friends, thank you for watching the video.